Logic gates are the fundamental building blocks of digital circuits. They process one or more binary inputs to produce a single output based on logical operations. These gates are used in almost every electronic device from computers to smartphones, enabling them to perform calculations and make decisions. Understanding logic gates is essential for anyone interested in electronics or computer science. In this video, we'll explore the different types of logic gates, how they work, and why they are so important in modern technology. Let's start by looking at the basic concept behind logic gates and how they fit into the world of digital electronics. Before diving deeper into logic gates, it's important to understand the binary system. Digital circuits operate using binary numbers, which consist of only two values, 0 and 1. These values represent the off and on states in electronic circuits. Logic gates use these binary inputs to perform logical operations, making the binary system the foundation of all digital electronics. By mastering the binary system, you'll have a much easier time grasping how logic gates function and how they are used to build complex digital devices. Logic gates play a crucial role in digital circuits by controlling the flow of information. They take binary inputs and produce outputs according to specific rules. These outputs can then be used as inputs for other gates, allowing for the creation of complex circuits that can perform a wide range of tasks. From simple calculators to advanced processors, logic gates are at the heart of all digital technology. Understanding their role helps us appreciate how electronic devices process information so efficiently. AND gate is one of the most basic types of logic gates. It takes two or more binary inputs and produces an output of 1 only if all inputs are 1. If any input is 0, the output will be 0. This gate is often used when a specific condition must be met for an action to occur. For example, in a security system, both a keycard and a fingerprint might be required to unlock a door. The AND gate ensures that both conditions are true before granting access. The OR gate is another fundamental logic gate. It outputs a 1 if at least one of its inputs is 1. This means that as long as any input is active, the output will be active as well. OR gates are useful in situations where multiple conditions can trigger an action. For example, a room light might turn on if either of two switches is flipped. The OR gate makes sure that the light turns on if any switch is activated. NOT gate, also known as an inverter, is unique because it only has one input. It simply reverses the input value. If the input is 1, the output is 0, and vice versa. This gate is essential for creating opposite signals in digital circuits. For example, if a system needs to turn something off when a sensor is on, a NOT gate can be used to invert the signal. Its simplicity makes it a vital component in many electronic designs. NAND gate is a combination of the AND and NOT gates. It outputs a 0 only when all its inputs are 1, otherwise the output is 1. This gate is widely used in digital circuits because it can be combined to create any other logic gate. NAND gates are the building blocks of memory and processing units in computers. Their versatility and simplicity make them a favorite among engineers designing complex systems. NOR gate combines the functions of the OR and NOT gates. It outputs a 1 only when all its inputs are 0. If any input is 1, the output becomes 0. NOR gates are often used in control systems where an action should only occur if no conditions are met. For example, a warning light might stay off unless all safety checks fail. This makes the NOR gate a valuable tool in safety and monitoring applications. XOR, or exclusive OR gate, is a bit different from the standard OR gate. It outputs a 1 only if an odd number of its inputs are 1. In the case of two inputs, the output is 1 if the inputs are different and if they are the same. XOR gates are commonly used in circuits that need to detect differences, such as error detection and data transmission. Their unique behavior makes them essential in digital communication. XNOR gate, or exclusive NOR, is the opposite of the XOR gate. It outputs a 1 only if its inputs are the same, either all 0 or all 1. This gate is useful in equality checking, where a circuit needs to know if two signals match. For example, XNOR gates are used in digital comparators to verify if two binary numbers are equal. Their ability to check for sameness is vital in many digital systems. Each logic gate has a unique symbol used in circuit diagrams. These symbols help engineers quickly identify the type of gate and understand how a circuit works. For example, the AND gate is represented by a flathead shape, while the OR gate has a curved input side. Learning these symbols is important for reading and designing digital circuits. As you become familiar with them, you'll find it easier to interpret complex circuit diagrams. Truth tables are a key tool for understanding how logic gates work. They list all possible input combinations and the corresponding output for a gate. By studying truth tables, you can predict the behavior of any logic gate in a circuit. This makes them invaluable for designing and troubleshooting digital systems. Truth tables provide a clear, organized way to see how inputs relate to outputs, making logic much easier to grasp. Logic gates can be combined to create more complex circuits. By connecting the output of one gate to the input of another, engineers can build circuits that perform advanced functions. For example, combining AND, OR, and NOT gates can create a circuit that only activates under specific conditions. This flexibility allows for the design of everything from simple alarms to sophisticated processors. Understanding how to combine gates is a key skill in digital electronics. Most modern logic gates are found inside integrated circuits, or ICs. These tiny chips contain thousands or even millions of gates packed into a small space. ICs are the backbone of modern electronics, powering everything from smartphones to cars. By miniaturizing logic gates, engineers have made it possible to create powerful devices that fit in the palm of your hand. Integrated circuits have revolutionized the world of technology. Logic gates are at the heart of all computing devices. They form the basis of arithmetic operations, memory storage, and data processing. Every time you use a computer, logic gates are working behind the scenes to perform calculations, store information, and manage tasks. Their speed and reliability make modern computing possible. By understanding logic gates, you gain insight into how computers process and manipulate data. You might be surprised to learn that logic gates are used in many everyday devices. From washing machines to traffic lights, logic gates help automate processes and make decisions. For example, a microwave uses logic gates to determine when to turn off based on timer and door sensors. Understanding their role in daily life helps us appreciate the hidden technology that makes our world run smoothly. Let's look at how you might build a simple digital circuit using logic gates. Imagine you want a light to turn on only when two switches are pressed. By connecting both switches to an AND gate, you ensure the light only activates when both conditions are met. This basic example demonstrates how logic gates can be used to control real-world devices with straightforward logic. Logic gates are essential in building memory circuits such as flip-flops and latches. These circuits store binary information, allowing devices to remember past states. Memory is crucial for everything from saving files to running programs. By combining gates in specific ways, engineers create memory cells that form the foundation of RAM and other storage devices. Arithmetic operations in computers, such as addition and subtraction, are performed using logic gates. Circuits called adders use combinations of AND, OR, and XOR gates to calculate sums and carry values. This allows computers to perform complex mathematical tasks at incredible speeds. Understanding how logic gates are used in arithmetic helps explain the power of digital technology. Digital communication relies heavily on logic gates. They are used to encode, transmit, and decode information, ensuring that data is sent accurately between devices. Error detection and correction circuits built from logic gates help maintain the integrity of data during transmission. This makes logic gates essential for everything from internet browsing to mobile phone calls. Programmable logic devices, or PLDs, are special chips that can be configured to perform different logic functions. They contain arrays of logic gates that can be programmed to create custom circuits. PLDs are widely used in prototyping and custom electronics, allowing engineers to quickly test and modify designs. Their flexibility makes them a powerful tool in modern electronics development. Automation systems, such as those used in factories and smart homes, rely on logic gates to make decisions based on sensor inputs. For example, a conveyor belt might stop if a sensor detects an obstacle thanks to a logic gate controlling the motor. By processing multiple inputs, logic gates help automate complex tasks, increasing efficiency and safety in various industries. Robots use logic gates to process information from sensors and make decisions about movement and actions. For instance, a robot might use an AND gate to move forward only if both its path is clear and its battery is charged. Logic gates enable robots to respond intelligently to their environment, making them more adaptable and capable. Security systems often use logic gates to control access and monitor conditions. For example, an alarm might only sound if both a window and a door sensor are triggered. Using an AND gate, logic gates help ensure that security measures are only activated when specific combinations of events occur, reducing false alarms and improving reliability. Modern transportation systems such as traffic lights and train controls use logic gates to manage signals and ensure safety. For example, a train crossing gate might only lower if both a train is approaching and the road is clear, using an AND gate. Logic gates help coordinate complex systems, making transportation safer and more efficient. Entertainment devices, such as video game consoles and televisions, rely on logic gates to process inputs and control outputs. For example, a game controller uses logic gates to interpret button presses and send signals to the console. Logic gates ensure that entertainment systems respond quickly and accurately to user actions, enhancing the overall experience. Medical devices, such as heart monitors and diagnostic equipment, use logic gates to process sensor data and trigger alerts. For example, a monitor might sound an alarm if both heart rate and oxygen levels fall below safe thresholds, using an AND gate. Logic gates help ensure that healthcare devices operate reliably and provide timely warnings to medical staff. Financial systems, such as ATMs and online banking platforms, use logic gates to verify transactions and ensure security. For example, an ATM might require both a correct PIN and card before dispensing cash, using an AND gate. Logic gates help protect sensitive information and ensure that financial operations are carried out safely and accurately. Educational tools, such as interactive learning platforms and digital classrooms, use logic gates to manage user inputs and provide feedback. For example, a quiz system might use logic gates to check if a student's answers are correct and display results. Logic gates make educational technology more interactive and responsive, supporting effective learning experiences. Summary: logic gates are the foundation of digital electronics, enabling devices to process information, make decisions, and automate tasks. From simple circuits to advanced computers, logic gates are everywhere in modern technology. By understanding how they work, you gain valuable insight into the inner workings of the digital world. Whether you're interested in engineering, computing, or everyday technology, logic gates are a key concept worth mastering.